This diagram illustrates a wet cooling tower, specifically a forced draft type. Here's a breakdown of the components and the process. Key components. Hot water inlet. Hot water, typically from an industrial process, enters the cooling tower. Water distribution nozzles. These nozzles spray the hot water evenly over the cooling fill. Cooling fill. This is a material, often made of PVC or wood, with a large surface area. It maximizes contact between the water and the air, promoting efficient heat transfer through evaporation. Air suction. A fan unit, located at the top in this diagram, draws ambient air into the cooling tower from the bottom sides. This is characteristic of a forced draft system, where the fan pushes air into the tower. Air outlet. The warmed, humid air, now laden with evaporated water, exits the top of the tower. Drift eliminators. These components are located above the water distribution and cooling fill. Their purpose is to capture large water droplets that might be carried out with the exhaust air, preventing water loss and minimizing environmental impact. Cold water basin. The cooled water collects at the bottom of the tower in this basin. Cold water outlet. From the cold water basin, the cooled water is discharged, ready to be reused in the industrial process. Process explanation. Hot water entry. Hot water from an external process enters the cooling tower. Water distribution. The hot water is sprayed downwards through distribution nozzles, creating a large surface area for contact with the air. Air intake. Forced draft the fan unit, positioned at the bottom, or in this case, drawing from the bottom and pushing up, forces ambient air into the tower from the sides. Heat transfer. As the hot water trickles down over the cooling fill, it comes into direct contact with the incoming cooler, drier air. A small portion of the water evaporates, taking latent heat from the remaining bulk water. This evaporative cooling is the primary mechanism of heat rejection. Drift removal. The air, now saturated with water vapor, passes through drift eliminators, which remove any entrained water droplets. Cooled water collection. The cooled water, having given up its heat, collects in the cold water basin at the bottom. Cooled water discharge. This cooled water is then pumped back to the industrial process to absorb more heat, completing the cooling cycle. Warm air exhaust. The warm, moist air is discharged into the atmosphere. In summary, this diagram effectively illustrates the principle of evaporative cooling in a forced draft wet cooling tower, where hot water is cooled by direct contact with forced ambient air.